And we are recording. Right. Yeah, I can hear us. In fact, I just heard you say that.
Can I say something bad about Dwight?
Fire away.
Dwight, you suck.
Oh no. Dwight, she doesn't mean that. She doesn't mean that, Dwight.
He's probably not even gonna watch it.
Oh, sure you will. You're gonna watch this, Dwight. Dwight, if you watch this and you come tell me the code word, I'll give you 2 extra credit points on your test. The code word is pineapple.
Oh.
We'll find out. Don't tell him. Don't tell him. We'll find out.
He's gonna need it.
All right, here we go. So, are you here?
Yeah.
All right, sweet. So we're gonna do the right side over here. So right. Okay. Start off with blue. So, step 1. Why am I making this blue? If we're on the right side of the heart, why blue? Deoxygenated blood. Good. So the first thing we're going to see happen is deoxygenated blood. It's going to enter the right atrium. From where? The inferior and superior, what? Vena cava. And that's why we're doing this, because so second hour, no one remembered this stuff. So I just wanted to make sure that we recapped this. This marks a intersection point within the entire blood pathway. So when this occurs, and you can do this just in a third color, like you just do this in just your pencil. This ends the systemic circuit. And it starts the pulmonary circuit. Yeah. It's up to you, whatever you want. This is for you. Okay, so we're going to see deoxygenated blood come into the right atrium through the inferior and superior vena cava. That's going to stop the systemic circuit and start the pulmonary circuit. So what do I mean by that? Well, the systemic circuit is where blood is going from the heart to the body and back to the heart, dropping off oxygen, picking up carbon dioxide. The pulmonary circuit is going from the heart to the lungs and back to the heart, dropping off CO2, which we exhale, and picking up oxygen from whenever we inhaled. Okay, so that's kind of this intersection point. So now we can show that happening here. So I'm going to put a 1. We're just going to kind of label this occurring. Okay, we're coming into the right atrium here. Okay, next thing that happens. Number 2. Remember that when the blood comes into the right atrium, this valve, what valve is this? Between the right atrium and right ventricle? The tricuspid valve. That valve is open. So this blood, as it enters the right atrium, is able to just fall straight through into the right ventricle. So we are going to see blood passively, and I spelled this wrong last hour. Let's see if I can get it this time. Passively, I think that's right. Flows into the right ventricle. And feel free to abbreviate things if you'd like. Okay, so if we were to add that to our diagram, you'd have number 2 here, and that blood is just going to kind of fall straight through into the ventricle. All right, at this point, you have deoxygenated blood in both the atrium. So I'm just going to kind of outline this thing in blue. And it's also starting to fill up the ventricle. Now, at this point, the ventricle is not full, because blood is just kind of passively falling into the right ventricle through that open tricuspid valve. So the right atrium has not yet contracted. Okay, so that kind of takes care of our first diagram here. We're going to move to the rest of the stuff that happens with the right side, to the next side, so it doesn't get cluttered. All right, questions up to here? Good? All right, move on over. So step 3. We are going to see right atrial systole. And this is going to send blood into the right ventricle. What does right atrial systole mean? The right atrium contracts. Good. So if we add that arrow number 3 here, right atrium contracts, thump. And that's going to force blood into the right ventricle. At the same time that this is happening, we're also going to be having the valve that leads out of the right ventricle. It's going to close to keep the blood from rebounding up and out of the right ventricle. So along with number 3, we're also going to be seeing, what valve is this? Between the right ventricle, what is it? The pulmonary valve, yeah. So pulmonary valve closes. Okay. How should I show that? I'm just going to draw an arrow to it. So pulmonary valve closes. Okay, that's step 3. Step 4. We are going to see right ventricular systole. And that is going to send blood through the pulmonary valve, into the pulmonary artery, and out to the lungs. I'm just going to use PUL for pulmonary. All right. There we will see out in the lungs our first round of gas exchange. So we're going to see pulmonary gas exchange. And pulmonary gas exchange involves oxygen going into the blood, and CO2 coming out. Okay. So let's show that occurring. So step 4 here, we have the ventricle contracting, contracts, and it's going to force blood out through those pulmonary veins. I'm sorry, pulmonary arteries. Out to the lungs. Okay. So at this point we would have blood down here in the ventricle. It's no longer in the atrium. All right. There's one other thing that needs to happen here. What have I not mentioned? What do you think? Oh, I'd be so impressed. What you got? When the ventricle contracts, what else has to happen?
Tricuspid valve.
Yes, tricuspid valve has to close to prevent backup. Tricuspid valve closes to prevent backup. Good, and that would be number 5. Right there. Let me get this thing squared up. There we go. All right. Good there? Okay, so that pretty much takes care of blood's movement through the right side of the heart. Now we're going to be talking about what happens at the exact same time over on the left side. So we're going to move over. We're now on the left side. Okay. At the same time as deoxygenated blood is entering the right atrium, we are going to be having oxygenated blood enter the left atrium. So that'll be step 1. Enters the left atrium. So via, it just means through. So via the pulmonary arteries or veins. Veins. This is the only set of veins in the entire body that carries oxygenated blood back from the lungs. So through the pulmonary veins, I'm just going to add from the lungs. From lungs. Okay. This marks the other end and start to the pulmonary and systemic circuits. So this is going to be the end of the pulmonary circuit, and it marks the beginning of the systemic circuit. So we went and we picked up some oxygen and dropped off some carbon dioxide, and now we need to reverse the process and drop off that oxygen to your body cells. Okay, so let's add that on our diagram here. So your pulmonary veins, since you have 2 lungs, are going to be located on both sides of the heart, and it's going to be this set of 4 vessels shown right here. So this would be 1 here, and here, and here, and here. On this side here, on the right side of the heart, those pulmonary veins are going to go behind the heart. So obviously we're not working in 3 dimensions here, but it goes behind the heart and links in back here to the left atrium. Okay, so that's step 1. And again, that happens at the exact same time as step 1 on the right side. We're just splitting it up to make this more clean. All right, step 2. We're going to be seeing blood passively flowing through this open valve. What valve is this? Mitral valve. Good. Also called the... What's the other name for it? Bicuspid valve. So mitral valve is what I've always called it. You'll also hear it called the bicuspid valve, though. Okay, so blood passively flows through the open mitral valve into the left ventricle. Okay. So we could show that for number 2. It's just going to fall straight through there. Because why? Why does it fall through there? Gravity. Exactly. Simply because gravity. The valve is open, so it just falls straight through. Good. Okay. So at this point, we would have oxygenated blood here. And it is starting to fill the ventricle, but it's not full yet, because we have not yet had contraction of the atria. All right. Last column. So step 3 now, we are going to have left atrial systole. And this is going to send blood into the left ventricle. At the exact same time, a valve has to close. And it's going to be this valve here that separates the left ventricle from its next step. So that's the aortic valve, yeah. So at the same time, the aortic valve has to close. Again, it closes to prevent blood from rebounding up into the aorta, which would cause a drop of pressure inside of this ventricle. We need this ventricle to be under high enough pressure to where the squeeze actually forces the blood out. Okay, so step 3 would be here. We would have the contraction of the atria, and that's going to force this blood down into the ventricle. And again, at the same time, the aortic valve must close. And at this point, we would have blood just down in the ventricle. It is out of the atria. Okay. 2 steps left. So, step 4, we have left ventricular systole. So the left ventricle contracts. And this sends blood through that aortic valve that we already talked about. Valve into the, what does the aortic valve separate the ventricle from? The aorta. And out to the rest of the body. All right. This is going to start the process of systemic gas exchange. Systemic gas exchange occurs between the blood and the body cells. And here we are going to have oxygen out of the blood and CO2 into the blood. Where did the CO2 come from? The waste of the cells when they performed cellular respiration, good, which involved the oxidation, so the use of this oxygen to combust glucose. Good, and that happens in the mitochondria. So this all kind of comes full circle with that process. So if we add in number 4 up here, number 4, we will have the ventricles contract. We will have blood go out through the aorta, up around the aortic arch, and then down it doesn't have the descending aorta on here. And then blood's also going to be headed off through the carotids as well to feed your brain. Next, that would all be step 4. Okay. One other thing we need to add on here. While that ventricle is contracting, what has to close? Mitral valve. Yep. If it doesn't, then blood backs up in the system. And we'll get into what leaky valve syndrome will cause in this unit. It's not good. Leaky valves. Okay, number 5, we will see the mitral valve close. Two, prevent blood backup. All right, that's a lot of stuff, but we just packed a whole bunch of information in a one-stop shop. So this is everything cardiac cycle. This is telling you where blood is flowing and when, where it's going. And what I like about this method here is that it gives us a reference of what's happening at the same time. So if you match up step number 1 on the right side and step number 1 on the left side, those are both occurring at the same time. Step 2 is occurring at the same time, and so on. So all of these are all synced up. Okay? All right. What questions do you have about this? Or do you need me to, like, pause on top of something? Okay. I'm going to post this video on Canvas so you can reference it whenever. Bye, Dwight. Remember, it's pineapple.